Okay, so in this session, we'll try to see like when we write a C program and when we compile the program, ultimately, what kind of files are generated, and we are going to see some more details about them. So let us first write the program. So let us say we are typing the program .c gmx. Let me include the standard files, include stdlib.h, include stdio.h, include unistd.h. Okay. Then we'll declare some variables. We will declare two global variables here. Now these two global variables would be used further in the program. Now among those two, we'll have one variable which is initialized one, int global first, say as say 10. We'll declare second variable int global second equal to. So we'll not initialize say for a while. This is uninitialized one. Then we'll write main, and in main we'll try to declare one local variable int local third, and we'll give value to this as 20. Now what we'll do is we'll store addition of first and third in second. So which is second is our global variable. Global second is equal to int global first plus int global, sorry, we have to take local, so local third. So we'll print this value. So result is %d, and then we'll print int global second. Let us hope that this program is syntactically correct. If it is not, we'll try to remove the respective errors. So let us say I'm writing a return 0. Let us save this and we'll go back to the shell prompt. Now what we'll do is we'll create a file which is executable. So let me create one folder first. KDIR online PGMs CD online PGMs CP dot slash online dot C. We'll copy it here. So currently we are having this .c program. So let us compile. So I'm using because my machine is 64-bit Ubuntu. So I have installed 32-bit libraries for this case. So GCC-M32 as a switch I am using, and then I am creating an executable for this program. So let us check what we got. So we got now two files. Okay. So we have a command called file, so which is used to identify type of the file. So let us see this particular file command manual. So this file, as I stated earlier, would be used to determine the file type. So let us use this command, this utility, to check out file type of a.out. So if I display this, you will see that it is showing us that it is executable and linkable file, 32-bit LSB, position independent executable. Okay, Intel 80386, and some things are displayed there along with saying that it is dynamically linked. Okay, and not strict. Now, as a compiler perspective, when we really compile a code, okay, and link it together, as a result, we get a.out, correct, directly. But there are multiple stages that translation process goes on till linking perspective. So like if we see this, like initially what compiler does is compiler applies pre-processing, and if we wish to see the pre-processed code uh, as an first stage, zeroth pass it is said to be. Okay, so we have to apply a switch dash E, though we haven't used any macro or something like that in our code, but we will see like how exactly it shows the thing. So if I use this dash E option, what it does, it displays that on the screen completely, whatever the output of that pre-processing is. So if I go up, this is the like these are the things that are added in, like if you see at the bottom, this is the code that you see that we wrote. Okay, and if I go, take scroll up for a while, so let me scroll up. So these are the things which are rather displayed uh, there. Okay, as an output of our preprocessor. So this is big. So like it would be a very big file. So if at all I wish to save this file, so I will show you how exactly you can save this file. Okay, this very big file rather. Okay, which is shown on your standard output, the translation as in a pre-processing perspective. So pre-processor actually done the pre-processing for the C code that you wrote. Okay, and this is what it is showing us over here. Okay, as an output perspective. So if I go up, 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 you will be seeing that at some point of time, it will show us the shell prompt, which we used earlier. Okay, yeah. So from here, rather, you may see from here, actually, it started displaying the pre-processed code. Now, if I want to save this one, so what I can do is I can redirect it to pre-processed online code, online C PGM. Let us say the pre-processed codes. If I see now, I can see that like you can check a number of bytes that are taken to generate this pre-processed version, a pre-processing stage of the compilation. So what we did was we used this particular command, okay, to generate that pre-processed version, and we wanted to save it, so we redirected that output to one of the file. Now, next stage is like after pre-processing, this pre-processed code is taken by the compiler, and then it generates an assembly code for this. So let us do this. So I'm writing dash capital S and dash M32 again, because I want to create this code, the assembly code to be, or assembly instruction to be used of Intel 32-bit. So I'm using M32. Now I'm writing online.c. So now if I check, I should see that there is one assembly code generated with .s as an extension. So if you open that through, if you display the contents of it, you'll be able to see this kind of code. Now you may see like few things are added there. There is something text, global, data, so on. Then your variable name is shown, then long, and that is the value shown. There is something called as global int, global second, BSS. Now you may identify here. Here we saw global and we saw data. For the second variable in a global second, we see global BSS. And then if I see global second, so it is showing that something like there is a difference between both the declarations in the assembly code. Now, what are the message that we included in the printf is created there as an one local variable, and there is something called as RO data too. We saw this data, we saw this text. There is something RO data. Let us go below. There is again text. Okay, the string is stored with .lc0, and if I go further, I should be able to see that there is a call given to the respective function printf. Okay, and this is the translation exactly that got generated there. Now, the addition that we carried out was seen over here. Like for example, if you see there is an add instruction added. So ECX and EDX are the two variables that are two registers that are used. So this is the like one of the variable probably. Okay, the 20 value which we assigned to one of the variable in the code. Like if I try to open this code in the other terminal, so you should see that like we assigned 20 to a variable int local third as a local variable. So it is using this particular mechanism to store this value. Okay, EBP minus 12 and 20 is assigned, correct? And if I see the code again, like the integer global second and the addition is saved here. So you can check here that int global second, int global first is moved to ECX. The second value, which is your local variable, is stored to EDX register, ECX register, and both of them are added and result is stored here with EDX. And then EDX value is saved or moved to the global second value. Correct. And then there is something called as return. So if we wrote return 0, you may see here. So we wrote here move 0 EAX, and then towards bottom there is return. Now there are few things which are added. Let us not much worry about this, right? For a while, we'll talk about them in greater detail in the later sessions. So what we saw was like if I use this command as a command switch for compilation perspective as -s, it generates the file. Okay, like the assembly code. Now further, like this output of assembly code is taken by the assembler to generate object code. So if you want object code to be generated, now like the command that we used earlier was file. So if I see file online.s, it shows you that it is assembler source. If you talk about .c, it says source. So it is identifying or differentiating between the contents of the file. Okay, and even if you give it to this P process, so it says C source only. Okay, it is not differentiating it with something else. Correct? Okay, now we want an object code to be generated where your assembly code generated by the compiler. Compiler's output is actually assembly code. This assembly code is given to the internal assembler called GAS, again GAS. So if I go and check for AS, this is the assembler, which is a GNU assembler, and that .s code is taken by GAS to generate object code. So what happens is if we use -c and your program name, say online.c, okay, and -m32. So it will generate now. One can check here. It should have generated now the object code. Now I can check it with file online.o. The way that we earlier saw with respect to the executable that was generated, correct? So you can see the difference between them. This .o is a relocatable file, okay, and this a.out is an executable file. So, and there is a difference. Both of them are though 32-bit LSB. This is executable and this is relocatable object code. And we'll talk about a bit after a while what exactly do we mean by stripped or not stripped. So now we have a .o available with us. Now what happens is as a further stage of compilation, uh, the object code is taken and then further an executable is created via a standard linker of Unix called LD. So this is the standard linker, GNU linker, which is used, which takes as input object code and standard libraries are automatically taken and then it generates an executable. So we do use directly this. Suppose if I write -m32 and my program name, correct? And if I want to give executable name, like if I don't give executable name, so by default, we have seen that it generates a.out. Now, if I want to give executable name, I can give this name to it as my exe. Now, if I now see again the files, one can check here, like my exe is generated. Now, if I apply file command again, the same output which we saw with a.out would be shown there. Correct. Now, you must have seen like during the translation process, we identified that this file is generated, correct? Okay, which was displayed on the standard output. Then this .s code was generated. Then this .o was generated, and then later executable was generated. So for each case, what we did was we applied these options. So let me recall again so that you can remember them. So this was the first one. which we generated, which we use to display the pre-processed code on the screen. Okay. Then we transferred the contents, redirected the contents to a file. So using this greater than option. Then further, what we used was we used -s option to generate what you can call it as uh, the assembly code. Later, we displayed the contents of that assembly code. Further, what we did was we created an object code by writing -c, which generates .o file. So we saw this file was generated, and then we again check type of that file, which was said to be relocatable one. And then lastly, like when you when you want to create your own executable name with your executable with your own name rather, so you can use -o option. Now, seeing here, like the C code is taken and file is generated. Now, there like for each of the case, for each of these file, whatever the file that was seen by us, rather that it is getting created. So compiler must be creating internally when I fire this command. Like for example, when I fire this command, correct? It must have created them, but it doesn't show us them. Okay. So if at all I want to check all the files, these files which are generated across, so I have to write dash save dash temps. Now, if I check this, you should see that these whatever the dot pre-processed code was, it is created with this dot I line. Now, this probably must be because I haven't written their -m32. So if I write -m32 for that option, then ultimately you will be seeing similar thing rather. So if you write this, now you can check the size. Okay, this file and this file is having same size, correct? Now, if I talk about this online S1611, this file again is having same size. Online.o 1404, online.o 1404, again same size. Your a dot out and this exe is same. So the option that we used here as save temps actually saved all the temporary files. If you don't want to apply separately the options to create an executable, this can be done. Now let us try to recall, like when we saw that object, the assembly code, we saw different parts of the code. Okay, now what they are. So we saw, like if I open that code, which was opened here, and the assembly code, say for a while, let's online.s. Okay, we saw that this is global, but one of them is defined or initialized, and other one is not initialized. So whatever the variable that was initialized is added into something called as data. Whatever the variable, like global second, I haven't initialized it. So this goes to something called as BSS. Okay. And the third thing is the local variable. Okay. And this local is not saved anywhere here. And that local goes to the stack. Okay. So the respective sections that are there added for your program. So if there is a command called size, okay, what it does rather, it displays you the what you can call it as size of the different sections which are added at the time of translation. So let me write man size. So you will see that this command permits you to display section sizes and total size of binary. So if I write now size, for example, if I take it to online.o, now let us compare this code. So we have a variable global first, which is initialized one. So we saw that it goes to data section. That's why this is 4 bytes. Correct. This was added into BSS because it is not initialized, but it is global. It goes to BSS. And then this local is not saved anywhere. So stack is not shown. So text, data, and BSS. These are the standard sections which are seen from the executable perspective or object code perspective. Text contains the translated code. Data contains all variables which are global variables but initialized. And BSS, meaning block starting with symbol, holds all variables which are not initialized. So let us do one thing. What we will do is we will try to rather modify this code, and we will add one variable each at one by one. Okay. Uh, as in a global perspective. So let us go to Emacs again. So what I'm doing is I'm adding here uh, again a variable. So let me say I'm not declaring again this value. So global var. I'm not defining this. Sorry, I'm not assigning any value to it. It is not initialized one. Let me save this. Okay. Let me come out. Let me apply the command now. So I will apply this GCC dash C dash M32. Fine. Now if I see this code, you should see that now as our code is containing two variables which are not initialized. So ultimately size became 8. So for every variable which is of type integer, it took 4 bytes. Okay. And now let us go and add the variable again here, which is I will make it as initialized one. Okay. Online.c. Now I will initialize that by say some value 50, say for a while. Correct. Let us save. Let us compile it again by generating object code. Okay. Now let us see the size. Now you should see now earlier, like when the variable was added as an local, sorry, as an a global, but not initialized. So we saw that time BSS was having size 8. Then we modified that variable value and we initialized it and we said that it is 50. So ultimately it shifted it to data section. Rest of the things are same. One can check it here. 20748 20784 219. Okay, so this is how the sections of the file can be seen, and how the translation process is done. Like I'm only trying to communicate here how the files are created respectively. So if I wish to see the same kind of command rather with my a dot out, which was generated. Okay, so you should see that now there are other things also added there. Okay, because this is an executable created. This is object code. So with before linking, you will see the exact details of your code. After linking, as the standard libraries are connected together as through the dynamic linkers, so you will see that their variables also are added there, and that's why one can see here approximately 300 bytes are added for initialized values, okay, which are global, and one 4-byte value is added into an uninitialized one, and that's how the things do work.